Alright guys, so let's do the chapter 3 test review part 1. These are questions 1 through 41, I believe. So let's look at this first one. Use the given figure to fill in the blank. Angles 2 and 6 are, we can see here that they are the corresponding angles. So let's quickly review what those are. So remember that when we hear the words interior and exterior, I need to focus on my transverse lines, these two lines right here, the ones that are getting intersected by the transversal. So this is your transversal and these are your transverse lines. So everything within these two transverse lines would be your interior, everything on the outside would be your exterior. If I'm focused on my transversal, this line, if I was looking at angle 1, for example, if angle 1 has same side angles as 3, 5, 7, everything on this left side. If I was looking at angle 2, the same side would be 2, 4, 6, and 8. And conversely, if I was looking at 2, the alternate side angles would be 1, 3, 5, and 7 on the other side of the transversal. So I know we are already really good at this, but this 1, 5, 3, 7, 2, 6, 4, and 8 are corresponding angles. 3, 6, and 4, 5 are alternate interior. 1, 8, and 2, 7 are our alternate exterior. And we have 4, 6, and 3, 5 as our same side interior. So here 2 and 6 are corresponding, 2 and 6. So let's move on. Here you need to, all this first sentence is telling you, use the 3D object, assume lines and planes appear, blah blah blah. All that is saying is that if it looks perpendicular, assume that it is. If they look parallel, assume that it is. They're not going to give us this sign and this sign, and they're not going to give us the little box. So line GC, so let's highlight GC. Line GC, which is right here, and line, oh no, it's GH, and line GC, where's GC? I messed up here. So GH is where? Where's GH? Right here. And GC is right here. What angle do these two guys form? Are they perpendicular? Are they parallel? Or are they skew lines? Remember, skew means that it's not perpendicular, not parallel, and not intersecting. So here we can clearly see that there is a 90-degree angle that gets formed here and here. So the answer is perpendicular. So let's look over here. Once again, lines MP. So let's do MP. MP's right here. And NR, where's NR? Right here on the back. I can clearly see that these two lines will not intersect. They're obviously not parallel, and they're not perpendicular. If it was perpendicular, I would need to have something here for this, or here for this, or here for this, or here for this. Here, there's a bunch of things I could do, but these two lines are skew lines because they have none of those properties in common. Now these are planes. So in orange, let's highlight plane CSH. CSH, so that's right here. And we also have plane QFE. QFE, it's right there. What do I know about both of these planes? This plane's on the right-hand side, this plane's on the left-hand side. So these planes are both what? Parallel. They're gonna keep on going forever in this direction and in this direction. Never ever actually intersecting, so parallel. Now let's look at these angles. Angle 3 and 1, what's the relationship between 3 and 1? These are same side interior, right there. 5 and 2, 5 and 2, these would be alternate because they're on other different sides of the transversal, and exterior because they're outside of the transverse lines. Okay, now with this question, This is very important. This first sentence right here. Identify all pair of corresponding angles for lines DE with transversal A. That means that this transversal A is the one I really care about. This transversal A is going to have all the corresponding angles that this guy's talking about. And now, if A is my transversal, what are my transverse lines? D and E. These other angles, C and B, are useless right now. So, if we look at my corresponding angles, remember corresponding angles have three criteria. They cannot be adjacent, they have to be on the same side, and one must be on the interior, one must be on the exterior. So if we take a look at 14, 14's corresponding angle is 13. 16's corresponding angle is 7. Now a lot of people might think that 15 and 11 are corresponding angles, but they're not. And why aren't they? Because of this space right here. Do you guys see this little space, this little angle right here? This angle is what's missing in order for 15 and 11 plus whatever this angle is. So if we had the rest of this angle, then we could say that this angle as a whole, this whole thing, both of these little angles, this whole angle is the corresponding of this one. So since I don't have it because this line C is cutting through this, I do not have the entire angle. So we cannot say 15 and 11. 15 and 11 are not corresponding. So the only ones I'm left with are 14, 13, 6 and 7. 16 and 7. There's a 16 there. 16. Okay. So let's look here, same thing, except now I'm looking for same side interior. So where on lines D and E with transversal line A. So A is my transversal, and my transverse lines are D and E. So what is it they wanted me to find again? The same side interior. That's pretty easy. That's 16 and 11. Once again, 6 and 9 do not work because this guy's same side interior is this entire angle. This 9 plus this 14. And since we don't have that whole angle, these two on their own are not same side interior. Okay. So what about this one? Identify all pairs of alternate exterior angles for the lines D and E with transversal line A. So once again, A is my transversal, and D and E are my transverse lines. So let's circle the alternate exterior angles. I have 7 and 14, and I don't have anything here. This is empty. So do I have any other pair of alternate exterior? No, I don't. So it's just 7 and 14. 7 and 14. Okay, so let's look at this one. This is saying to look at what they gave you and determine if this is true or false. So line JR, so let's highlight line JR. Line JR is parallel to line ND. Is that true? Definitely not. These look like they're skew lines because they have nothing in common. They're definitely not parallel, they're not perpendicular, and they don't even intersect. So my answer has to be false. So I can go ahead and take off this answer and take off this answer. So let's read this answer. False, because JR and ND are coplanar lines that intersect to form a right angle. Wait a minute. We just said that they don't intersect. They do not intersect. So this one is wrong. So the only one left is this one. False, because JR and ND are non-coplanar lines that do not intersect. Okay, so this right here gives you the giveaway that is the answer. Once again, they want a true or false. So plane NPF, where's NPF? Right here. NPF is parallel to WQV. Where's WQV? Right here. So we have this plane in the front of us, over here in the front, and we have one in the back. These planes right here are indeed parallel because they won't intersect. They're going to keep going in this direction and that one, and this direction and that one, never actually touching each other. So I can go ahead and take off all the falses. So let's look at this first one. True, because planes, whatever, intersect each other. Whoa. They don't intersect each other. They're going to keep going in their directions, but never actually crossing paths. So this answer is wrong. So the answer is, whoops. Yeah, this one's wrong. So the answer is C. True, because these planes do not intersect, and the symbol parallel means it's parallel to. Yeah, we know that. Okay. So this one's really easy. Sketch 2 lines and a transversal. So 2 lines and a transversal. It should look something like that. Which the only one that actually looks like that is B. And how many pairs of alternate exterior angles do I have? Well, I have 2 and 7, and I also have 1 and 8. How many pairs was that? It was 2. So please do not say 4. Do not say 4. It is 2 pairs. Okay? Alternate exterior angles are right angles. Okay, is that always true, sometimes true, or never true? So, in the case like this, right? If I have something like this, if this angle was 40 degrees, then this angle would have to be 40 degrees as well, because these are alternate exterior angles. So this is a situation where this is actually not true. They're not. No, this is actually wrong. We have, this is an example of this is an example that counteracts this guy. Alternate exterior angles are right angles. Well, these are alternate exterior angles and they're not right angles. So now, is there a situation we can come up with where this statement is actually true? Well, if I have 2 transverse lines and a straight line down like that, that forms 90 degrees. Well, if this is 90 degrees, this one's also 90 degrees. Are these still able to be alternate exterior? Yes, they are, because this is 90 and this one's 90, and this is valid. Okay, so this is right sometimes and it's wrong other times. So what do I put? Sometimes it's true, sometimes it's not. Okay. Use lines M and N with transversal T to select the answer that correctly completes the sentence below. So 4 and what else are alternate interior angles? Well, 4 is alternate interior angles with 10. So that's why my answer was 10. Okay, now we're getting into 3.2. Remember that 3.2 is all about using our theorems. We have the alternate interior angles theorem, alternate exterior angles theorem, corresponding angles theorem, and the same side interior angles theorem. Remember our little template that we used. If blank angles are congruent, then lines are parallel. We also have the under supplementary here. So these two are very important. So whatever I decide to put on here, I can continue reading this. So let's say I wanted to put if alternate interior. So if alternate interior angles are congruent, then the lines are parallel. Now this whole sentence right here is my alternate interior angles theorem. So, and then you would only use supplementary when this is not alternate interior, when it's actually same side interior. So this would read, if same side interior angles are supplementary, then the lines are parallel. So remember, I'm only gonna say this once because I say it every day in class, right? If you're given your angles, you are going to use your theorems to figure out if the lines are parallel. If you're given that your lines are parallel, you're going to use the converse to figure out what the missing angle is. So right now on 3.2, we're only focused on theorems right now. In other words, we're going to be given our angles. We're going to be given our angles, and we want to find if the lines are parallel. So let's look at that. Let's look at these two angles. These two angles are what? These two angles are alternate interior angles that are congruent. How do I know they're congruent? Because they have one arc each. So now I can indeed say that line M and line N are parallel because of the alternate interior angles theorem, which tells me if my alternate interior angles are congruent, then my lines are parallel. Which lines specifically? The transverse lines, M and N. So yes, because the alternate interior angles theorem. Once again, let's look at these. Is there any relationship between these two? No way. So this could be, no, it cannot be determined. What can't be determined? It cannot be determined if these two lines are indeed parallel. These two angles tell you absolutely nothing about if these two lines are going to be parallel, so you would put no, cannot determine. Let's take a look at this one. What about these two angles? These two angles are alternate because they're on each side of the transversal, and they're also on the exterior. So these are alternate exterior angles. And I know that if alternate exterior angles are congruent, then my lines are parallel. That's what it means to be the alternate exterior angles theorem. So yes, the lines are parallel by the alternate exterior angles theorem. So now, in the given figure, which lines are parallel? So which lines are parallel? Remember, the most important thing is to identify which line is your transversal. Your transversal are the lines. Well, here, how many transversals do I have? I actually have one transversal, 2, 3, and 4. So when you have more than, like usually we've seen it like this, where there's only one transversal. But in situations where you're gonna have more than one, in this case you have 4, you need to identify which is the transversal you want to focus on. And the transversal that you want to focus on are the ones that contain both of your angles. In that situation, HD would be my transversal. Now, your other thing you need to do is figure out, okay, which one are my transverse lines? Because these transverse lines that you highlight in blue, we're going to highlight in blue, these are going to be the lines that are proven parallel by the corresponding angles theorem. Okay, so what's my transverse lines? KH and CD. So KH and CD are parallel because of the corresponding angles theorem, these two guys, which tells me that if my corresponding angles are congruent, then my lines are parallel. Which lines? The transverse lines, these two. KH and CD, corresponding angles theorem. So, which segments are parallel? When you're given segments parallel, it's okay to extend everything. So, let's not worry about that right now. What is my transversal line here? Remember, my transversal line is the line that contains both my angles. So I could say that my transversal line is line NH, or I can say it's HF, or I can actually say it's NF. But it doesn't really matter which one, because lines do what? Do lines just stop at the vertices that you said? So line NH is just right here, N and H, from here to here? No. Line NH starts at your N, goes to your H, but then it keeps going in both directions. So I have this line. Now I need to identify, okay, what are my transverse lines? Well, my transverse lines are the lines that contain my desired angles. In that case, it's AN and it's RH. This is 90, this is 90. What do I know about these two angles? These two angles are actually your corresponding angles, right? Because they're on the same side of the transversal. They're non-adjacent, they have this gap between them, and one is on the interior, one's on the exterior. So lines NA and RH are parallel by the corresponding angles theorem. So I have this right here. I have now I have 4 transversals again. So I need to focus on which one is the transversal I really care about. It's asking me, given the figure, in the figure given, which lines, if any, are parallel. So remember, my transversal line is just the one with my given angles. It's usually the one with 2 angles. So what if I wanted to say that K is my transversal? Well, if K were to be my transversal, do 110 and 75 have anything in common? Or do they have any special properties together that will let me know if in this case, P and Q are parallel? No. 110 and 75, they're not congruent and they're not supplementary either. So it's completely useless. I don't care about K right now because it's not going to tell me anything about the property of parallelness, if that's even a word, of P and Q. So my real transversal that I really care about is P. Why P? Because it contains the angle 110 and this angle 110. And what do you know about the position where both of these congruent angles are? These are on the alternate, and exterior angles. So I know that which lines are now parallel, K and M, by the alternate exterior angles theorem. K and M by the alternate exterior angles theorem. So let's take a look at this one. This one's really hard. So I have a lot of lines and segments and angles. So let's just focus on the most important thing, which is finding my transversal line. My transversal line here is W. Why W? Because W literally has every single angle. Has everything. So we have 2 options here. We have N and U, and I have S and T. So let's take a look at S and T. If I were to extend this S like this, so I can view my entire transversal, right? What do I know about the relationship between 97 and 96? Well, they are in corresponding positions to each other, right? They're on the same side of the transversal. They're non-adjacent. One's on the interior, one's on the exterior. However, what do you notice about these? Even though they are corresponding angles, are they congruent corresponding angles? No. One is 97, one is 96. So that means these are not congruent corresponding. So it doesn't tell me anything about if S and T are parallel. So I need to start over because S and T are not going to be my answers. What are going to be my answers? If I take a look, if I extend this transverse line N and this transverse line U, now what angles do I get formed? This is the part that's tricky for people. The angle that gets formed between the intersection of this N and this W is not 18 and it's not 97. It's actually both of them. It's 18 plus 97. You see this entire angle? This entire angle is the addition of this angle plus this one. This is an application of the angle addition postulate, right? So what is 18 plus 97? I think that's 115, if my math is right on that. Yeah, 115. So now, what about this one? What is this angle right here? What is 19 plus 96? That's also 115. So now I have corresponding angles that are actually what now? Congruent. And if I have corresponding angles that are congruent, then the lines, the transverse lines, are parallel. So now I can say that N and S are parallel by the corresponding angles theorem. Whoops. Oh, I meant to say N and U. N and U. I think I said S and T by mistake. So N and U are parallel by the corresponding angles theorem. N and U by the corresponding angles theorem. So, okay, find the value of x for which D and M are parallel. Okay, so in order for D and M to be parallel, I'm gonna need to make these two angles what? What do I know about these two angles given here? This angle right here and this angle right here in these positions are what? These are alternate interior angles. And what do alternate interior angles need to be to prove lines are parallel? They need to be congruent. So I'm going to do 2x minus 28 equals 84. Because if the angles are congruent, then the measures of these angles are equal. So plus 28, that's going to give me what? 8, 6, 2, 96, 116, right? Divide by 2, divide by 2. That's going to give me, I don't know, 5, 8, 58, I think. Okay, 56. My math here went wrong somewhere. So, let's do it, because why not? 28 plus 28 plus 28. 2, 1. There we go. Now that's 5, 6, 56. So my x is 56. Okay? Now let's look at this one. Use the given information to determine which lines, if any, are parallel. Justify each conclusion with a theorem. So if I know that 8 and 12 are supplementary, so where's 8 and 12? 8 and 12. So 8 and 12 are supplementary. This actually works out really well because what is the position that this angle 12 and this angle 8 have? This is on the interior of these two transverse lines, and they're also on the same side of this transversal line, right? So in this case, what is my transversal? In other words, what is the angle? What is the line that contains both my desired angles? In this case, what are my desired angles? 12 and 8. So which line contains both of them? Not just one, both. That would be B. So B is my transversal. And what are my transverse lines? Well, N has 12 in it and 8. And M has 8 in it. And what do I know about 12 and 8? They are supplementary. And what do I know about this angle and this angle? They're same side interior angles. So now I know that line N and M are parallel because of the same side interior angles theorem, which tells me that if my same side interior angles are supplementary, then my lines are parallel. So N and M by the same side interior angles theorem. Use the given information to determine which lines, if any, are parallel. Justify each conclusion. So now we're given that angle 2 is congruent to angle 4. So where are 2 and 4. Well, this is perfect. What is my transversal? My transversal is line R because it contains both my desired angles. Now, what are my transverse lines? That would be M and N. Why? Because they contain each angle, each one of these angles. So now, what is the relationship between 2 and 4? They are in corresponding positions. And if they're corresponding angles that are also congruent, then I know that the lines are parallel. So M and N are parallel because of the corresponding, right? Corresponding angles theorem. Good. Okay. Using information to determine which lines, if any, are parallel. So 7 and 12. So 7 is congruent to 12. So where's 7? Right here. And where's 12? Okay, cool. So first step, what is my transversal? My transversal is N because it contains both of them. What is my transverse line? Well, R contains 12 and S contains 7. So now, if I can prove that the alternate interior, alternate exterior, or corresponding angles are congruent, then I can say that lines R and S are parallel. Or if I can prove that if I can say that the same side interior angles are supplementary, then I can also prove that R and S are parallel. So what is the relationship between angle 12 and angle 7? Well, they're on the interior of the transverse lines, and they're on alternate sides of the transversal. So these are alternate interior angles. And we know that if my alternate interior angles are congruent, then my lines are parallel. So R and S are parallel because of the alternate interior angles theorem. Okay. So let's do 25. Find the value of X that makes M and N parallel. Okay, so M and N need to be parallel. So that means that M and N are automatically my transverse lines because these are the ones that I want to prove that are parallel. And what's my transversal? My transversal is this line right here. Now, is 17X, is this part of M or N? No, so then it does not matter. So now, this 16X and this 14X don't have a direct correlation. There's nothing here and here that tells me that, hey, if these guys are supplementary or if these guys are congruent, blah, blah, blah. But I do know that vertical angles, if this is 16X, then what is this angle right here? That's also 16X because vertical angles are congruent. So now, if this is 16X, and this is 14X, well, now, if I can make both of these angles, what? What do I have to make both of these angles? This angle and this angle are what? Same side interior angles, right? Because they're on the same side of the transversal and on the interior of the supposed transverse lines that I want to prove parallel. So if I can make these guys supplementary, then these M and N will be parallel. So how do we do that? Well, let's find what the value of X is. 16X plus 14X equals 180. So X equals 6. So my X value is 6. If my X value is 6, then this angle and this angle will be supplementary, which proves parallelness of the transverse lines. So now, this is when it starts to get a little bit harder, right? Because now I need to find out what my angles are by the fact that I know what my parallel lines are. So before, for 3.2, this is 3.3 now, 3.3. Before, I was using the fact that they gave me the angles to prove if the lines were parallel. Now, we're on 3.3, and 3.3 talks about the converse. The converse is the what? The switching of the hypothesis and conclusion, which tells me that if my lines are parallel, then my corresponding angles are congruent, or my alternate interior angles are congruent, or my alternate exterior angles are congruent. The other converse is that if my lines are parallel and my same side interior angles are supplementary, if my lines are parallel, then my same side interior angles are supplementary. Okay, so now we are given that the lines are parallel. So now let's try to prove that the angles are congruent, or if the same side interior angles are supplementary. So let's take a look at this one. So what is the measure of this angle 1? Well, this angle 1 is going to be 65. Why 65? Because this angle and measure angle 1 are what of each other? They are alternate interior angles. And I know that if my lines are parallel, then my alternate interior angles must be congruent. How do I know that? Because of the alternate interior angles converse. Now, how do I find the measure of angle 2? Measure of angle 2 is actually also 65 degrees. So now I know that. How do I know that? I know that because 65 and the measure of angle 2 are what of each other? They are in corresponding positions. Therefore, they are corresponding angles. And I know that if my lines are parallel, then my corresponding angles are congruent. So I can say that the reason that 2 is 65 is because the angle whose measure is 65 and 2 are, because the measure whose angle is 65 and the corresponding angles converse. Corresponding angles converse right there. Okay? So let's look at this one. Same thing. Find the measure of 1 and 2 and justify my answer. So the measure of angle 2 would be what? 109. How did I know that? Oh, whoops. I guess we should do 1 first. So 1 is what? 71, right? 71 degrees. Why is it 71 degrees? Because once again, my lines are parallel. And if my lines are parallel, then my corresponding angles are congruent. So measure of angle 1 and the corresponding angles converse. Now, the measure of angle 2, you could think of 2 ways to do this. The measure of angle 2 is 109. But there's a couple reasons why it's 109. Now, if you're looking through the perspective of your measure angle 1, you would say that measure angle 2 is 109 because of angle 1 and the same side interior angles converse, which tells me that if my lines are parallel, then my same side interior angles are supplementary. And if I would have taken that 180 minus 71 from here, I would have gotten 109. Now, if you look at it through the perspective of your 71 degrees, you could say the angle whose measure is 71 degrees and linear pair theorem, because this angle right here and this angle 2 equal 180. Why? Because these two are a linear pair. So it just depends on what your drop box gives you. So you have to look at every single opportunity and figure out your reason for why it is what it is. So now, use measure of angle 3 is equal to 66, and now find the rest of your angles. So 3 is 66. So let's write that here. So the measure of angle 3 is 66. So if angle 3 is 66, then what else is 66? Well, the measure of angle 1 is 66 because the measure of angle 3 and the vertical angles theorem. because I know vertical angles are congruent. Now, we are going to compare everything in reference to measure of angle 3, okay? So now, what's the measure of angle 2? Well, the measure of angle 2 is, what is 180 minus 66? $114. So this is 114. Now, how do I know that? Because the measure of angle 3 and linear pair theorem, because these two guys form a linear pair. What about 4? It's 114 as well. Why? Because of the measure of angle 3 and linear pair theorem. Now, you could also say the measure of angle 2 and vertical angles theorem. But if they ask you for looking at it through the perspective of 3, you have to pick 3 and linear pair. You cannot do 2 and vertical angles. Okay? So what is the measure of angle 5? That is 66. Why? Because these two are what? Alternate interior angles. And if I have parallel lines, then my alternate interior angles are congruent. So I can say 3, the reason why 5 is 66 is because of angle 3 and the alternate interior angles converse. Now what about 6? 6 is 114. Why? Because of angle 3 and the same side interior angles converse. What is 7? 7 is 66 because of 3 and the corresponding angles converse. Okay? And now, 3 and 8 is a little bit special because 3 and 8 don't have a relationship that you can go directly from there. So I can't use 3. So I'm going to use the fact that 6 and 8 are vertical angles. So I can say that 8 is 114 because of the angle 6 and vertical angles theorem. Okay? So we have more of the same here. Use the measure of angle 5 equals 157. So if measure of angle 5 equals 157, let's do this kind of quick, right? The measure of angle 1 is also 157 because of what is this and this? These are corresponding angles that lie on parallel lines. So we can say that these two are congruent by the corresponding angles converse. Measure of angle 2 is 23. So 23. Because of what? Because of the same side interior angles converse. What about 3? Angle 3 is 157 because of, remember, I'm doing everything in regards to 5 through the perspective of 5. So 5 and the alternate interior angles converse. What about 4? Hello? Okay. 4 is 23, but I actually cannot use 5 here, so I'm going to use 2 and vertical angles theorem. What about 6? 6 is 23 because angle 5 and a linear pair. Angle 7 is 157 because of measure angle 5 and vertical angles theorem. And last one, measure of angle 8 equals 23 because of measure angle 5, because of angle 5 and linear pair theorem, because these two form a linear pair just like how 5 and 6 form the linear pair. Okay, so let's look at this one. Find the values of x and y. So what is the value of x? Well, I have here that these angles are parallel, and if these angles are parallel, then this angle and this angle are what? They're alternate exterior, and if two lines are parallel, then the alternate exterior angles are congruent. So x is 122. So, and what is y? Well, I know that this 122 and this y form a linear pair. So 122 plus y equals 180. I can subtract 122, subtract 122. That's going to give me 58. 122 and 58. Now, what is the value of x? Well, that one's pretty easy because 80 and x form a linear pair. So this is 100. And if x is 100, then what is y? Y is also 100. What's the reason for that? Because x and y are corresponding angles that lie on parallel transverse lines. So I can say y is 100 because of angle x and the corresponding angles converse. Okay? This is another one that's really hard, and we're actually going to go over this in class because it's going to be more efficient to look through it. I guess we can go over it now, but this question is probably going to be the hardest one on your test. So we'll definitely go over it, 3.3.25. So let's just do it real quick. Well, I know that the measure of angle 1, I know that 73 and 1 form a linear pair, correct? So what's 180 minus 73? That is, I think, 107, right? Yeah, 107. Now, I know that angle 1 is 107 because 73 degrees, and 1 because of 73 degrees, this angle 73 degrees, and linear pair, this. Now, I know that 4, listen, I cannot go directly from 1 to 2. I can't do that. So I'm going to have to do a bunch of steps along the way. Well, I know if angle 1 is 107, angle 4 is also 107. Why? Because of the corresponding angles converse. And if 4 was 107, 3 is also 107. Why? Because of the corresponding angles theorem. Look, corresponding angle, corresponding angle. So you see how our perspective is switching depending on what we're looking at, and that's okay. Over here, when we were looking at 1 and 4, this was my transversal, and these are my two transverse lines. So 1 and 4 are corresponding. That's okay. Now, if I'm looking at 4 and 3, what's my new transversal? This one, and these are my two transversed. So I can also say that this and this are corresponding angles in that perspective. Now, if angle 3 is 107, then what is angle 2? It is also 107. Why? Because of the vertical angles theorem. So that's pretty much what it says here, but we're going to go over it more later in class if you guys want. This one too. So we can go over it more specifically, but I know that the measure of angle 1 is also going to be 35. Why? Because of the alternate interior angles converse, right? And, okay, how do we want to do this? So, oh yeah, so now we can find out the measure of angle 2 because angle 1 and angle 2 are just what? Same side interior angles. And if I have parallel lines, the same side interior angles are supplementary. So this is 180 minus 35, which is what? 145. And if angle 2 is 145, so is angle 3 because of vertical angles. And now measure of angle 4 would also be 145. Why? Because of the measure of angle 2 and alternate interior angles converse. So 2 and 4 are going to be congruent. Same thing, so I'm going to leave that for class because I don't really want to go over it right now. It's better in person. So this 44 degrees and this 22x degree are what of each other? These are just alternate interior angles. And if these alternate interior angles are on parallel lines, then these two are just equal to each other. So 44 is equal to 22x, so my x is just what? 2. This 58 and this 2x are just what? Alternate exterior angles. So I just have to equal these to each other because alternate exterior angles that are on transversals, that are on transverse lines that are parallel are just what? Congruent. So this should be 29. 29. So after a while, it does get easier. You just gotta practice and practice. Now, what am I supposed to do with these? So there is no direct relationship of this 4x plus 6 and this 36. So I'm gonna have to do an extra step. I know that this 36 right here and this angle right here are the same. Why? Because of vertical angles. So now this is also 36 degrees. Now this 4x plus 6 and 36 do have a relationship. They're what? They are same side interior. And same side interior angles are supplementary. So I'm gonna have to do 4x plus 6 plus 36 equals 180. And if I solve for x, I'll get my answer. Now here, once again, when you're looking at these, it's going to be easier to extend your line. So let's extend this line. And let's extend this line. If we extend both of these lines, then I can clearly see that these would be my transversals. These two are my transverse lines. And what's my transversal again? My transversal is the line that contains my desired angles. I want this angle and this angle. So let's form this line in orange. And now it's easier to see that this and this are just what? Same side interior. So I'm gonna have to do x plus x minus 46 equals 180. Okay? So x plus x minus 46 equals 180. And I think you guys can do the math on your own, right? There's going to be 2x, add 46 to the other side, and now whatever you got, I think that's 226, you divide, and there's your answer. So, same thing here, right? Let's extend both of our parallel lines. If we extend both of our parallel lines here, now I can see which one is going to be my transversal. My transversal is the line that has my desired angles. So let's put a transversal here. And now, what is the relationship between this angle and this angle? These are just corresponding, right? And corresponding angles that lie on parallel transverse lines are congruent. So I gotta set this equal to this. Same thing here. This line and this line, if we extend them to easier see our parallel lines, right? Because of this. So this, parallel lines. Now I can extend this transversal here. And what do I know about this angle and this angle? They're just same side interior. So 3y plus y plus 12 equals 180. Now let's look at this one. Now this one has a different transversal, right? Because now I want different angles. I care about different angles. I care about the angles that have these x's on them. So what do I know about this angle and this angle? They're also same side interior angles. that lie on parallel transverse lines. So these are supplementary. So I'm going to have to do 4x plus x minus 20 equals 180. And now last one. When two parallel lines, so on your test, when two parallel lines are cut by a transversal, are the same side interior angles ever congruent? Well, here, if this angle is 80 and this angle is 100, are they congruent? No. So was your answer no? It's not, because I can also draw two transverse lines and one transversal straight down, which is going to give me 90 degrees here and 90 degrees here. These are supplementary, right? Yes. These are also supplementary, yes. So these both show parallelness, except that here they're not congruent, here they are congruent. So when two parallel lines are cut by transversal, are same side interior angles ever congruent? Yes, because if both same side interior angles are right angles, then they are congruent. So only in this situation. So be careful with this question. All right, well, that's it, guys. So I know I didn't do a lot of the algebra, but